Greetings. Very quickly, I'll be discussing with you on inverter output waveforms. There are basically three types of waveforms most inverters generate, depending on design, which are the pure sine waveform, modified sine waveform, and the square waveform. There are other, waveforms you could get, but these are the three that most inverters use. Now, these square waveforms are found in older inverter designs. This is how the waveform looks like. Okay, it's just a turning on and turning off kind of waveform, which generates so much noise. There's so much noise content in the output. All right. The disadvantages of these square wave inverters are much, which includes the efficiency drop. Okay, the efficiency of this inverter is actually low, very low as compared to the modified sine wave and the pure sine wave. Now, you notice that square waveforms, inverters that produce square waveforms, when used with sensitive electronics like your laptops, and then when you go to musical instruments, you notice some buzzing sound that is normally reflected, on those appliances. Then in inductive loads, like your motors, electric motors, your fans, your fridge compressors, okay, those inductive loads, they don't perform well, with a square waveform. In fact, as a matter of fact, heat is being generated on the windings of those motors, of those inductive loads over time, which of course can reduce their performance and lifespan. So this is not recommended at all. Now, the next one I'll discuss is the modified sine wave. Modified sine wave in design is actually a square wave, design with an addition of a dead time. All right, dead time is added, which is a time off between the switching of those two pulses. If you are a designer, you understand what I'm trying to say. Now, the two pulses that your IC, your main control IC generates, okay, the PWM pulses that your main IC generates, which is used, to switch the MOSFETs, Now, a dead time is introduced to ensure that those two pulses don't come on at the same time. There will scarcely be any time where two of them will switch on, even if it's in milliseconds or microseconds. So a dead time is introduced. Now that dead time now creates this clip-in. This clip-in you can see here. You can see some part of this signal will have been clipped off. Can you see? Okay, so that's what the dead time do. And then it reduces the noise content in this output here. Now I want to move on to the pure sine wave. This is actually the best among the three, the pure sine wave. Now, this waveform here, mimics what you get from your generators and your grid supply. So this is what you get from your grid, all right, and then your generators. Now, this is smooth and clean, and then, does not produce all those buzzing noise you hear from whether your, the appliances that uses the modified sine wave or the square wave. So this is actually recommended. All right, so I will show you how this look like on the oscilloscope shortly. All right, now let me show you. Now what we use here, what we are using here at the office, we are using a modified sine wave inverter. Now let me show you how the waveform looks like, okay? This is our socket here. Now, can you see the screen? This is actually how a modified sine wave output is. Okay, you can see it in real time. All right, now this is a solar generator. It gives a pure sine wave output. Now let me show you how it looks like. All right, you can see now this is a pure sine wave. You can see it as clean as possible. All right, so that's what we're talking about. I don't have a square wave inverter here, so I would have shown you how it looks like graphically.